Okay, now let's look at the second type of vulnerability that might exist within machine learning, and this is data poisoning attack. And the way that it works, the attacker tries to manipulate the training data that cause the model to behave in an undesirable way. This is significantly important because a lot of developers who try to train their models, usually they are downloading this from public repository. Let's say they are getting their data sets from Hugging Face, from Kaggle, from GitHub. And so you don't know really what type of data exists there because there are millions of inputs or millions of rows within the table. So it's extremely hard to check them one by one and see which one might be malicious. So imagine that you have a model that you have trained for autonomous cars. So autonomous cars are going to look at the sign on the road and decide that what to do about it. If they see a stop sign, they're going to stop. If they see a maximum speed, they're going to try to set that as a threshold. Or if they see a yield sign, they have to yield to the cars that are passing on the main road. Now, if the model being trained with malicious or adversarial training data, the machine or the autonomous car, whenever it gets to the intersection, might actually ignore the stop sign and might pass, or might ignore the red traffic light and they might pass. So you see that's actually jeopardizing the safety of the passengers. So there are some other examples like training in spam classifier. The attackers can inject maliciously labeled spam emails during the training. So the model think that the email that they are seeing is not malicious because the label says non-malicious or is a no issue packet. So in that case, in the future, if the model also sees such emails, they believe that there's no issue with that, and they let that pass. So the user will receive that email, they will click on that link probably, and then the network going to be compromised. The other one is training a network traffic classification system. Let's say they can have a lot of examples that are incorrectly again labeled and causing the model to to classify traffic in an incorrect category. So the threat is very obvious here. And again, this is the attacker inject malicious data into the training data. You see what is the difference between this one and the number one that we discussed in the previous video. In the previous OWASP issue that was input manipulation, here you try to manipulate the image itself or manipulate the input. But here in this attacks that is data poisoning, you try to provide some inputs that are malicious or they behave in a specific way that can break the intended behavior of your machine learning algorithm. And this is usually happens because might be a lack of validation or insufficient monitoring. That's pretty normal actually, because again, if you have a very huge data set, probably you don't have time to walk through the entire data set. There's some techniques to stop this. One of them is data validation and verification. If you are getting a data set, you have to check it, look at visualize it to see how the data is distributed. Make sure that the data is stored properly, use encryption. And if you are transferring the file, use, for example, the secure version of FTP or over HTTPS to make sure that someone cannot inject their own data to the training. Data separation, make sure that the data that is used in the development area or production is separated from those training data. Access control, who has access to the training data? So, like someone malicious or with bad intention cannot get access to the training data and modify it. And you may want to do monitoring and auditing. So you monitor the training data for any anomalies. You want to do model validation. So it's actually very important because you want to divide your training or your entire data sets into training and validation sets. So you see how's the performance of the model on training set and how is it on the cross validation set. And if you see like different behaviors, that's gonna make you double think about it because something is off there. I mean, could be other reasons too, for example, overfitting or underfitting, but also there could be a chance that there are some data that are behaving differently. And model ensembles, which means that you have multiple decision trees. Each of them make a prediction, and at the end you do the vote over all the decision. Let's say four models says like four decision trees says a packet is malicious. One of them says it's not malicious. So you'd get the conclusion that it is malicious. And anomaly detection, again, you have to look at the distribution of the data to see if there is any anomaly in your data. Okay, so let's move on to number 3.